Hi guys, this is summary for the chapter 6, the network layer. So the network layer, what is the network layer? The network layer of the OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes: addressing end devices, encapsulation, routing, the encapsulation. So what's the difference between those four? So first is addressing end devices. End devices must be configured with the unique IP address for identification on the network. Encapsulation. The network layer encapsulates the protocol data unit from the transport layer into a packet. The encapsulation process adds IP header information such as the IP address of the source and the destination. So what is routing? The network layer provides services to direct packet to destination on another network. To travel to another network, the packet must process by a router. The role of the router is to select the best path and directs packet toward the destination host in the process known as routing. Uh, a packet may cross many intermediate devices before reaching the destination host. Each router a packet across to reach destination host is called a hub. Now, what's the encapsulation? The encapsulation. The encapsulation is the reverse process for the encapsulation. When the packet arrives at the network layers, the destination host, so next is the host, checks the IP header of the packet. If the destination of the IP address within the header match its own IP address, the IP header is removed from the packet. After the packet arrives the network layer of the destination host, the host check the IP header of the packet. If the destination IP address within the header matches its own IP address, as I said before, the IP header is removed from the packet. After the packet is encapsulated or remove the IP header by the network layer, the resulting layer of 4 PDU is passed up to the appropriate service of the transport layer. Um, so next is the network protocols or the network layer protocols. These are several network layer protocols in existence. There are only two network layer protocols that commonly implemented: the net, Internet Protocol version 4 and the Internet Protocol version 6, or the IPv4 and the IPv6. Legacy network layer protocols are, are going to discuss later. Next is next is encapsulating IP. IP encapsulates the transport layer segment or other data by adding an IP header. This header is used to deliver the packet to the destination host. The IP header remains the same time the packet leaves the source host until it arrives in the destination host. The process of encapsulating data layer by layer enables the services as the different layers to develop of um, and scale without affecting the other layers. This means that the transport layer segment can be ready packet by IPv4 or IPv6 or by any view protocols that might develop in the future. Routers can implement these different network layers um, protocols to operate currently over a network. The routing perform of these intermediate devices only considered the content of the network layer packet header. Then the characteristics of IP. Now we'll go. What is the characteristics of IP? IP was designed as the protocol over with low overhead. It provides only the function that are necessary to deliver a packet from a source to a destination over an interconnected system of network. The protocol was not designed to to track or manage the flow of the packet. Then IP. IP is connectionless, meaning of this that no dedicated end-to-end connection is created before the data is sent. Connectionless data communication work on the same principle. IP requires no initial exchange on control information to establish um, end-to-end connectivity before packets are forwarded. IP also does not require additional fields in header to maintain and or an established connection. This process reduces the overhead of IP. Then IPv4 packet header. An an IPv4 packet header consists of fields containing important information about the packet. These fields contain binary numbers which are examined by the layer 3 process. The binary values of each field identify various settings of IP packet. Protocol header diagrams which are read through to left to right and top down provide a visual to refer to when discussing protocol fields. There are significant fields of IP packet. The the next is the differentiated service or diffserv serve, and the time to live and protocol, then source IP addresses are address, then the destination IP address. The version contains a 4-bit binary values to set to 0100 that identifies that are this as an IP version 4 packet. Differentiate service or diffserv, formerly called the type of services field. The DS field is an 8-bit field to determine the pro- priority of each packet. The six most significant bits of the fields is differentiate service code point, and the last two bits are the explain congestion notification. Then the time to live contains an 8 bits binary value that is used to limit the lifetime of the packet. The protocol fields is used to identify the next level protocol. The source IP address contains a 32-bit binary values that represent the source um, IP IP addresses of the packet. The destination IP address. It contains 32-bit binary values that represent the destination IP address. Then, limitation of the IPv4. Of course, IPv4 has also a limitation. Through the years, the IPv4 has been updated to address new challenges. However, even with changes, IPv4 is still has three major issues. Those three major issues is IP address depletion, internet routing table expansion, lack of end-to-end connectivity. IPv4 has a limited number of unique public IPv address. Sorry for the interruption. Although there are approximately 4 billions of IPv4 address, the increasing number of the new IP-enabled devices, always-on connection, and the potential growth to less developed regional has increased the need for more addresses. Then the internet routing table expansion. A routing table is used to router to make best path determination as servers or as the number of their server connected to the internet increases. Then the lack of end-to-end connectivity, network address translation is a technology common implemented with IPv4 network. Then so those are the three major issues on IPv4: the IP address depletion, the internet routing table expansion, and the lack of end-to-end connectivity. So the latest version of IP is the IPv6. So in early 1990s, the Internet Engineering Task Force or IETF grew concerned about the issues with IPv4 and began to look for a replacement. Because IPv4 is only a limited numbers, so it is not enough for many devices around the world. So this problem leads to the development of the IP version 6 or IPv6. IPv6 becomes or overcomes the limitation of the IPv4 and is a powerful enhancement with features that better suit current and foreseeable network demands. So improvements that IPv6 provide include the increased address space, improved packet handling, and limiting the net need of NAT. So encapsulating the IPv6. One of the major design improvements of IPv6 over IPv4 is the simplified IPv6 header. For instance, the IPv4 header consists of 20 octets or up to 60 bytes and 12 basic header field. As highlight for the IPv6, some fields had remained the same, some fields have become challenges or changed names and proposition, and some IPv4 fields are no longer required. Then um, IP packet header. The field in IPv6 packet header include version, traffic class, flow level, payload length, next header, hop limit, source IPv6 address, and destination IPv6 address. Then host forwarding decision. Another role of the network layer is to direct packet between hosts. A host can send packet to itself, local host, and remote host. So a host can send a packet to either itself or even the local host or and the remote host. Then default gateway. If we're talking about gateway, the first thing that come in my mind is about the gate or the entrance. The default gateway is the network devices that can route traffic to another network. It is the router that can route traffic out of the local network. Alternative, a PC or computer that does not know the IP address of the default gateway is like a person in a room that does not know where the doorway is. They can talk to each other or to other people in the room or the network, but if they do not know the default gateway address or there is no default gateway address, there is no way out. It is just like a room without a door. So, how can you enter or exit a room without a door? It's the same in at the internet. How can you enter or exit the internet if there is no default gateway? Then, using the default gateway. How can we use the default gateway? A host routing will typically include a default gateway. The host receive the IPv4 address of the default gateway either dynamically from the dynamic host configuration protocol or configure manually. Then host routing tables. Entering the netstat R command on the equivalent route print command display three six sections related to the current TCP RIP network connection. Interface list, IPv4 route table, and IPv6 route table. So there are the display session related to the current TCP IP network connection. Then next word is a router is a computer. There are many types of infrastructure router available. In fact, Cisco routers are designed to address the needs of the many different types of business and networks. The branch, one, and service provider. Branch, teleworker, small business, and medium-sized branch site include Cisco integrated switch routers. One, largest business organization enterprises include the Cisco Catalyst Series switch and the Cisco Aggregation Services router. Next is the service provider. Large service providers include the Cisco ASR, Cisco CRS, 3 carrier routing system, and the 760 series router. So for this video, this is all about the my summary for the chapter 6, and thank you.